Hi everyone, let's see one of the question on functional dependency. Find functional dependency preserving or not for the given decomposition relations, right? So here they have given the relation as R with set of attributes are A, B, C, D, and set of functional dependency as F, set of decomposed relations are D, and this decomposed relation contains four relations AD, CD and AB, right? So if you would like to define whether it is functional dependency preserving or not, you have to find out set of functional dependencies possible for the relation R1, I can call it as F1, set of possible functional dependencies for the relation R2, I can call it as F2, and so on. Set of functional dependencies possible for the relation Rm, I can call it as Fm. Finally, you make them all combine and you need to find out its closure if it is equal to the set of functional dependencies which are given in the FD set, I can call it as F. For that, if we find the closure, if now both are same, I can call it as FD preserving. I can say that FD preserving is done on the decomposition. Otherwise, I can say that FD is not preserving. Okay, guys, if you want clarity, you can go with the previous videos, right? Then you can come up with here and you can solve this question, right? So to solve this question, first take out the first decomposed relation AD. Try to define all the FDs which are possible on the relation AD, right? So I can say that A is one kind of FD possible. So for that reason, I am trying to find out A closure. If you find out the A closure, from A I can get A, from A I can get B, from B I can get C, from C I can get D, right? So this is the FDs, this is the closure happening on A. Now is A determines A is considered? No, because it is in the same relation, trivial. A determines D is not going to be considered? No, A determines D is going to be considered. This is in the same relation, and A determines BC is not going to be considered because these are two are out of relation. So you are going to get only one possible FD with respect to A, that is A determines D. Similarly, find out D closure. You are going to get D. From D, are you going to get anything? No. So nothing FD is possible with respect to D. Similarly, if you are going to find out AD closure, you are going to get trivial along with maybe possible some other things. Those are not in our relation, right? Yes. Similarly, try to find out the relation CD. What might be the set of FDs possible, right? So set of FDs possible maybe starts with C, right? If I find out starts with C, you are going to get C, and from C you can get D. Any other things? No. So simply I can say that C determines D is one of the FD possible here. Similarly, find out the D closure, nothing is possible, and CD closure, anyway you are going to get trivial as well as non-relational FDs, right? So you should not consider that. Similarly, go with the other relation AB. If you are going to find out the set of FDs possible for AB, you can able to find out A closure, that is A, B, from B I can get C, from C I can get D. Anyway, C and D are not in our relation, A is a trivial, so A determines B is possible. Similarly, find out B closure. B closure, if you are going to find out, you will get B, from C, B you can get C, C you can get D, and you know these two are out of relation and you should not consider. B determines D is a trivial, so no FD is possible with respect to B. Try to find out AB closure, you are going to get trivial along with some other attributes may be possible which are not in our relation, so I can just simply skip this one. Now finally, see, these are the set of FDs possible for the relation AD, I can call it as F1. These are the set of FDs possible for the relation R2, I can call it as F2. These are the set of FDs possible for the relation R3, I can call it as F3. Now try to check any of the functional dependencies are not preserving in the sub relations for the actual functional dependency, right? So if I take A determines B, is it possible? Yes, it is possible. Is B determines C is possible? No, B determines C is not possible. But you have to check whether it is going to be happen in indirect manner or not, right? So try to check, is A determines D is one FD, C determines D is one FD, another one is A determines B, right? So they are asking for B determines C. B determines C. Anyway, if you are able to apply transition rule, can we get this one? No, it is not possible. So B determines C is not possible. Okay. C determines D. Yes, C determines D is possible. Right? As at least one of the FD is not preserving in the subrelations, I can call it as FD not preserved, guys. Right? So here we are trying to find out some of the FDs possible or not, right? So for example, here they are asking for B determines C. So what you are trying to do? We are trying to find out B closure on these FDs on the subrelations, right? So you are going to get only B. That's why it is not possible, right? So this is where you can say that closure property is applying, right? Yes, this is the way you can able to solve when you got the question like FD preserving or not. I hope you understood clearly. Thank you.